Good afternoon, everyone. Hello.
Good afternoon, ma'am.
Hello.
Yes, ma'am.
क्या बात है, सब धीरे धीरे आते हो हैं। 4 मिनट हो गए, 2 बजे से सेशन स्टार्ट हो गया था और अभी
जो
भी
लास्ट क्लास है मैम वो 2 से बाद ही मतलब ओवर होती है, 2 के बाद ही।
सर को बोला करो 5 मिनट पहले ही 12:55 पे ही ले लिया करें, या तुम्हारी जब 12:45 ही ले लिया करें ताकि जल्दी खत्म करते।
अगर मैम आपकी अगर क्लास नहीं होती आज तो 2:30-3 बजे तक ही लेते क्लास, मतलब एक्स्ट्रा क्लास ले लेते।
फ्राइडे को ले लेते होंगे फिर।
हाँ मैम, वो मतलब एवरी डे है उनका तो।
चलो अच्छी बात है, एक तो तुम्हें पढ़ाने वाले मिल रहे हैं।
मैम
हाँ
सर
मैम,
का बस चले तो 12 बजे से 2 बजे तक पढ़ाते हैं।
अच्छी बात है ना, इतना पढ़ाते हैं सर, बताओ कितने अच्छे
मैम
सर
फिर
है।
हमें फ्री टाइम नहीं मिलेगा ना।
अरे क्या करना है फ्री होके।
मैम ये आशीष मैम क्लास लेते लेते लंच करता है मैम।
अरे ये तो
मैम
आशीष,
हमें भी तो।
तुम आशीष की बात कर रहे हो, मेरी छोटी बेटी है। तुम लोगों को तो हम कैमरा भी नहीं ऑन करने के लिए कहते हैं, उसको तो कैमरा भी ऑन रहता है, वो तब भी। मेरी बेटी जो है वो लंच करते करते या ब्रेकफास्ट करते करते क्लास लेती है, और उनकी टीचर्स कुछ नहीं कहती।
मैम जो क्लास के बीच का टाइम होता है ना मैम, उस बीच में तो हम नहा नहा के आते हैं कि जल्दी जल्दी चलो।
चलो स्टार्ट करें। कल हमने
यस मैम।
हाँ, कल हमने कहाँ छोड़ा था, यही सर्किटरी व्यू ऑफ 3 वायर्स आरटीडी था ना, एक्सप्रेशन 4 यहीं पे छोड़ा था ना कल हमने, expression for a 3 wires RTD circuit.
यस मैम।
Now you can see here, if we know the values of Vs and V0, we can find Rg, and then we can find the temperature value using calibration equation. Now assume R1 is equal to R2. This is the RTD circuit, 3 wire RTD circuit, R1, R2, R3. You can see here. Then V0 is equal to Vs bracket R3 upon R3 plus Rg bracket of minus bracket Vs upon 2 bracket close. If R3 is equal to Rg, then V0 is equal to 0 and the bridge is balanced. This can be done manually, but we don't want to do manual calculation. We can just solve the equation 3 to get the expression for Rg. That is Rg is equal to R3 bracket Vs minus 2V naught upon Vs plus 2V naught bracket close. Now this expression assumes when the lead resistance RL is equal to 0, suppose if RL is present in a situation, then the expression of Rg becomes Rg is equal to R3 Vs minus 2V naught, यहाँ से ले लिया हमने, Vs plus 2V naught minus RL 4V naught upon Vs plus 2V naught. So there is an error in the RTD resistance value because of the RL resistance. That is why we need to compensate the RL resistance as we discussed already by connecting one dummy line C. या हमने ऊपर आपने देखा होगा जब हमने C line कनेक्ट की थी 4 वायर में और 3 वायर में भी करी थी. This is the dummy line. ठीक है, किसी को कुछ पूछना है? RTDs are very simple रेजिस्टेंस की कैलकुलेशंस की हमने यहाँ इक्वेशंस यूज करी है. जस्ट राइट इट डाउन, देन वी विल डू टुडे LVDT. फटाफट लिख लीजिए एक्सप्रेशन सारी. Done?
No, ma'am. Yes, ma'am.
सारी इक्वेशंस लिख ली. LVDT कर ले आप. Yes, class done.
Yes, ma'am.
Okay. Now next is LVDT, and that is linear variable differential transformer. This is another type of transformer. You can see its construction: primary coil, secondary coil, armature. Now the definition. Now the definition is the term LVDT stands for linear variable differential transformer. It is the most widely used inductive transformer that converts the linear motion into electrical signal. The output across secondary of this transformer is the differential, thus it is called so. It is very accurate inductive transducer as compared to other inductive transducers. This is the diagram. Now the construction of LVDT. Firstly, the main feature: the transformer consists of a primary winding P and two secondary windings S1 and S2 wound on cylindrical former. You can see here it is a cylindrical former, wounded primary winding and secondary windings. Both the secondary windings have an equal number of turns, and we place them on either side of the primary winding. The primary winding is connected to an AC source which produces a flux in the air gap, and voltages are induced in secondary windings. A movable soft iron core is placed inside the former, and displacement to be measured is connected to the iron core. The iron core is generally of high permeability, which helps in reducing harmonics and high sensitivity of LVDT. The LVDT is placed inside a stainless steel housing because it will provide electrostatic and electromagnetic shielding. Both the secondary windings are connected in such a way that resulted output is the difference between the voltages of two windings. You can see here, this is the primary winding and the two secondary windings are there. The number of turns in both the secondary windings are same. Now the principal operation and working. As the primary is connected to an AC source, so alternating current and voltages are produced in the secondary of the LVDT. The output in secondary S1 is E1 and in the secondary S2 is E2. So the differential output is E out is equal to E1 minus E2. Now this equation explains the principal operation of LVDT. You can see here E out is equal to E1 minus E2. Now three cases arise according to the locations of the core, which explains the working of LVDT. Case 1, when the core is at null position, that is for no displacement. When the core is at null position, then the flux linking with both the secondary windings is equal. So the induced EMF is equal in both the windings. So for no displacement, the value of output E out is 0, as E1 and E2 both are equal. So it shows that no displacement took place. Case 2, when the core is moved to upward of null position. For displacement on the upward for reference point, in this case, the flux linking with the secondary winding S1 is more as compared to flux linking with S2. Due to this, E1 will be more as that of E2. Due to this, output V voltage E out is positive. कहाँ जाएगी अगर ये ऊपर की तरफ जाएगी, ठीक है ना, और अगर ये नीचे की तरफ जाएगी towards E2 downwards, फिर देखते हैं क्या केस है. Now in case 3, when the core is moved to the downwards of null position for displacement to the downward of the reference point, in this case, magnitude of E2 will be more as that of E1. Due to this, output E out will be negative and shows the output to downward of the reference point. Now out of Vs4 displacement, a linear curve shows the output voltage varies linearly with displacement of core. You can see LVDT is null position, in phase and out of phase. Now इससे पहले ये लिख लेते हैं, फिर करते हैं some points. Write down from the definition, then its construction and the part. All of you just write down the definition and let me know. LVDT very important, again important है LVDT.
Done, ma'am.
No. Just write the main construction point of LVDT. Done.
No, ma'am.
Done.
Okay, ma'am.
Write out the principle of operation and working with the diagram. Make the diagram also. Done. Write down the 3 cases.
No, ma'am, डन नहीं हुआ था, मैम.
नहीं हुआ था? ये बोलते तो हो नहीं लो. लिख लो. हो गया?
No, ma'am, diagram.
थोड़ा स्पीड बढ़ाओ बेटा सब लोग.
हो गया, मैम.
Write down the 3 cases. Done. Ranjan, mute yourself. So much noise is coming. Yes, class done. Is class done? Hello, hello, hello. Is class, just let me know if you are writing, then
Yes, ma'am.
हो गया या लिख रहे हो अभी?
Yes.
हो गया, ठीक है. Next is now some important points about magnitude and sign voltage induced in LVDT. The amount of change in voltage, either negative or positive, is proportional to the amount of movement of core and indicates amount of linear motion. By noting the output voltage increasing or decreasing, the direction of motion can be determined. The output voltage of a LVDT is linear function of core displacement. Now the advantages of LVDT: high range. The LVDT have a very high range for measurement of displacement. They can be used for measurement of displacement ranging from 1.25 mm to 250 mm. No frictional losses as the core moves inside a hollow former. So there is no loss of displacement input as frictional loss. So it makes LVDT a very accurate device. High input and high sensitivity. The output of LVDT is so high that it does not need any amplification. The transducer poses a high sensitivity, which is typically about 40 volt per mm. Low hysteresis. LVDT shows a low hysteresis and repeatability is excellent under all conditions. Low power consumption. The power is about 1 watt, which is very as compared to other transducer. Direct conversion to electrical signal. They convert the linear displacement to electrical voltage, which are easy to process. Disadvantages of LVDT. LVDT is sensitive to stray magnetic fields, so it always requires a setup to protect them from stray magnetic fields. LVDT gets affected by vibrations and temperature. Next is application of LVDT. We use LVDT in the application where displacement to be measured are ranging from a fraction of mm to few centimeters. The LVDT, acting as a primary transducer, converts the displacement to electrical signal directly. The LVDT can also act as a secondary transducer. Example, the Bourbon tube, which acts as a primary transducer and it converts pressure to linear displacement. And then LVDT converts this displacement into electrical signal, which after calibration gives the reading of the pressure of fluid. Now this was the LVDT. Just write it down the points. Meanwhile, I'll take your attendance. Make this diagram also. Output versus forward displacement. लिखते भी हो कि नहीं? Just time pass करते हो? Yeah, चलो, it's good because books नहीं है आपके पास. Just make the diagram. I will scroll down the screen. Ashish Shukla.
Present, ma'am.
Anish Ranjan. Anish is there or not?
Yes, ma'am.
Anish, आप कल आए थे क्लास में?
No, ma'am.
आप नहीं आए थे, मुझे लगा कल आप आए. निधि, निधि को क्या हुआ है? निधि, प्रभा, आपकी बात हुई थी निधि से? बाकी क्लासेस अटेंड कर रही है निधि?
यस मैम करती है अटेंड, पता नहीं अभी क्यों नहीं कर रही है.
ठीक है. पारस बत्रा, पारस नहीं आया आज? पीयूष?
Yes, ma'am.
प्रभा? प्रद्युमन?
Yes, ma'am.
राहुल गौर?
Yes, ma'am.
राजीव? राजीव भी नहीं आ रहा. रंजन?
Yes, ma'am.
ऋषभ रॉय? ऋषभ भी नहीं आया। सौरभ,
Yes, ma'am.
विजय सिंह,
प्रेजेंट मैम।
यश शर्मा। बना लिया डायग्राम? स्क्रॉल डाउन कर दो।
यस मैम।
Yes, ma'am.
Write out the advantages and disadvantages. You can write only the first part. जैसे advantages में high ranges, no frictional losses, खाली ये भी लिख सकते हो। कोई लग रहा है कि important है, you can write the full also. Just write and let me know. Yes, class done. Advantages. हेलो
मैम हो रहा है मैम, 2 पॉइंट रह गया।
स्क्रॉल डाउन कर दो फॉर द डिसएडवांटेजेस।
Yes, ma'am.
Disadvantages and applications. LVDT important part है.